Hey, good afternoon. I have no idea what was said there, so I'm going to go with he was saying I was pretty. So, thanks for coming out. I guess you didn't really have a choice but to come to this session. So, what we're going to talk about today is aspect-oriented programming. We're not going to show any in code, so no Visual Studio, but we're going to talk about what it is in theory, the differences between it, and how you can implement it. By the time you leave here, I hope that you can have enough interest and enough knowledge to be able to at least go out and research which way may work or not work for you on your projects. So let's get going then. So AOP is a interesting topic. It's a complementary topic. So it's not a product and it's not a pattern, really. It is a technique, something like object-oriented programming. The big thing that AOP allows you to do is increase the modularity of your code. So you're able to write what we call aspects that do specific things. The most common one people talk about is logging. So you can write a logging aspect. So now you've got a nice modular piece that you can replace or change without affecting a massive amount of your code base. So that's what aspect-oriented programming is going to give us. Usually these things that we do in modules are what we call cross-cutting concerns. A cross-cutting concern is an area in the application that covers many different pieces. So something like logging, you'll find in maybe up in your model view controller area of your code base if you're doing a web app. You might find it down inside your data access layer. You may find it inside your business logic. So it's all throughout the application or in multiple locations when you look at the architecture of your application. So that's a cross-cutting concern. So there's any number of things that you can do that are cross-cutting concerns in AOP. Logging is the canonical example that everyone uses, and it's quite possibly the most boring example. Because how many of us like looking at log files, right? So we want to do something more interesting, and a really good example that's more interesting is the use of aspect-oriented programming to manage database transactions. So we can take and wrap our code with transactions and say this area here needs to be encapsulated inside of a transaction. Instead of us writing begin transaction code, whatever needs to happen, then commit or roll back, we can just say, apply that pattern into this area of code, and it will happen automatically for us. So that's a really, well, somewhat more interesting use of it. We'll take a look at why this pattern of do something, then run the code that you're wrapping, and then do something else is one of the fundamental patterns in aspect-oriented programming as well. So these are the three main pieces that we should take from AOP. It's a programming paradigm, like OOP. It does modularity, and then we have cross-cutting concerns that we work with. So the big thing when I say that it's a programming paradigm is this is absolutely not programming language dependent. There's AOP for .NET, there's AOP for Java, there's actually AOP for JavaScript. Don't ask me why you would use it, but there is. It is a product, or it is a pattern, not a product. It is, you'll hear a lot of people say, well, we don't do OOP, we do AOP. Yeah, no, you do OOP and AOP. They're complementary, not exclusive. The one thing that I'll hear a lot of people say is, we're going to have no more boilerplate code in our data or in our code base because we're doing aspects for everything now, and it's the greatest thing, and it gets rid of all this duplicate code. No, it gets rid of duplicate code, absolutely, but it's not a silver bullet to all your problems. The one thing, this slide says that it's a first-class citizen in Java and .NET. That's a little misleading. You'll hear people say that, well, we can do it in these languages and it's built for these languages. The fact is that if you go look at the .NET framework or the raw Java frameworks, there is no AOP baked into those. And if you're on the .NET side of things, Anders and Mats, who basically run the languages at Microsoft, have explicitly said, we're not going to do it. So if you're doing this, you're doing something outside of the .NET framework. You're not using the framework itself. So we talked about this, what it's not, what it is. It is a pattern. It's a great tool for your toolbox. I use it on almost every project, but not every project. So it's one of those things. It's good, but it's not something you use all the time. And it is something that's really easy to add into your languages. So like I said, it's in JavaScript. It makes no sense to me that someone's done it in JavaScript, but they have. So what we want to do with the modularity piece of our talk in AOP is that we want to be able to take these pieces of our application that are replicating functionality or replicating patterns and bring them down so that they're in one place. You're probably familiar with single responsibility pattern, or SRP, single responsibility principle. This says that we should have code in one place and one place only, basically. We don't want duplication, we don't want repetitiveness, and we want it to have one job and one job only. So what we're saying is instead of having this logging code spread all throughout the code base, let's bring it into one spot. Let's make this spot only responsible for logging. Not everywhere else responsible for logging plus whatever else it does, but just this one spot. So we want to encapsulate it down. And one thing you can think of when you see aspects that have been written is that they very much are well-encapsulated pieces of functionality. If they're doing more than one thing, it's probably not a very good aspect. It should do one thing. It should do logging. It should do database transaction management. It should do injection of the iNotify property change pattern, things like that. Only one thing. If you write your aspects well, which I don't suggest you trying to do straight off, you can move them from project to project. Your initial goal writing aspects is make it work for whatever project I'm working on now, and then the next project you take that same idea, refine it a bit, and then maybe on the third project you've got something that you can just drop in. But they should be that modular and that well encapsulated, that you can take them and drop them project to project. And we'll see a little bit of that when we start talking about one of the platforms in .NET, how they've managed to do that with the tool and what types of droppable aspects it has. So cross-cutting concerns, we talked about that, there being these pieces of code that are all over through your code base. How many people here have seen logging in classes all over the place, or in methods everywhere? You go into the method, first line of code, log that we entered this method. Do a bunch of stuff, log that we exit this message. Next method you go to, log that we entered this method. It starts to look like it's cluttering your code base, right? And that's when you can tell that you've got a cross-cutting concern, is because it starts to feel like it's hiding what these methods and classes are really trying to do. So anything that looks like that is probably a cross-cutting concern. And that's a prime candidate for AOP. So really you're looking for repetition, right? Look for repetition, and once you find it, start thinking about it. The one thing that's key when you're looking for repetition is look for repetition in infrastructure-related pieces. Don't look for repetition in your business logic or things like that. We don't want to use AOP on business logic. We don't inject some kind of business logic aspect. We inject aspects that are related to connecting to databases, maintaining connections across network failures, doing transaction management, things like that. Not, we need to apply all of the taxes for this region to invoice. So this, when you're looking for repetition, look more so at infrastructure type code. So this is our standard pattern that we see in our code base, right? Log that we were in here. Do something, log that we exited. And then, you know, if you're a really good programmer, you'd actually have a try catch and you'd say, log that we screwed this shit up. This is another piece of code that you'll probably see. It has no logging in it whatsoever. That very well might have an aspect attached to it, though. That's a lot easier to read and understand than having a whole bunch of log entries buried in and around it. How many people do smart client development? You know, WPF, Windows Phone, stuff like that? A few of you. I notify property change pattern. You had to implement that? Yeah? You drink a lot after doing that? Yeah, it sucks. This is one property on one class. You have to implement this pattern. There's events that have to be implemented. There's callbacks to the event that have to be implemented, which is this on-property change. Every property in your class that's bound into the UI has to have this done to it. If that isn't the definition of boilerplate, I don't know what is, right? And as humans and developers in combination, we're going to screw this up. Sooner or later, you're going to forget that bottom line to call on property changed. Well, now I notify property change doesn't work. That's just what's going to happen. So it would be nice if we could use something that injected this pattern into our code base for us, and we just say this class needs it, or this class needs it over here, and that's done. And this is what AOP can do. So when we look at our standard pattern for building an application, we usually have, up at the top, we usually have some kind of viewing pattern, UI pattern up there, right? This is MVVM, so for WPF or Windows Phone type of thing. This could be MVC, or it could be MVP, or it could just be WinForms with code behind or something like that. We then have some data model type, or sorry, service layer. This may be implemented and exposed through WCF or RESTful endpoint using Web API or something like that. We have some kind of business logic area and some kind of data access layer. And these are all very nicely segmented, hopefully, in our architecture and our code base. We then get these cross-cutting concerns, right? Logging is going to exist through a whole bunch of things. Maybe we have security. Security we might do in the UI, but we also might do it down here at the service layer because we want to make sure that nobody can get through our Web API without having their authentication and authorization done. We might have auditing that does stuff down at the database level and maybe at our Web API level so we can tell who uses the system. And we might have some kind of validation. These are the types of cross-cutting concerns we normally see in applications. Then we get all kinds of other cool stuff. Those are the boring ones, right? Nobody gives a shit about security. I notify property change. Undo, redo. How many people have been asked to put undo, redo functionality in a business application so it works like Excel or Word or something like that? It's pretty common, I think. Business likes that kind of stuff, right? How easy is it to write that kind of code? Not so easy. You've got to maintain the state of what happened in all these previous steps. What happened when I roll back? What are the future go forward to do redo? All of that type of thing. But it's infrastructure. It has nothing to do with business functionality. How many people write multi-threaded code? Few people? Yeah? It's hard, isn't it? Not easy. Certainly not as easy as, doing drag and drop. Here, we'll just put a grid over here and a button there. Threading's hard. And there's so many different thread management systems that we can use. So we can do threadifine. We can do reader, writer, lock. And if we decide to do these patterns, we have to implement them all by hand and do them all over in our code base where it's needed. How many people do unit of work or know what unit of work is? Right? It's a database pattern somewhat related to transactioning. It allows you to do multiple updates to data and then say, okay, I'm done all of these things, these changes, now push it to the database altogether. When we start implementing that, that's a cross-cutting concern because it'll start to float between service layer down through to your data access repository type stuff. Anyone know the circuit breaker pattern? No? Tomorrow we'll talk about it in depth and you can learn about it. It's a great pattern for helping us do retries. So if you're accessing a external web service or web API endpoint, you always want to retry if it fails, right? One failure might just mean the packets got dropped. Big deal. Should retry a number of times. And that's what circuit breaker does. And if you want that kind of logic, it's going to be throughout your application where these calls off to external dependencies happen. So another cross-cutting concern. So when we get all of this stuff decided and looked at, and we're ready to implement AOP, we have two choices for how we're going to do AOP. And really, these are the only two choices for styles. There's interception, and there's Ioweaving. Interception is something that's much more related to inversion of control containers, IOC containers, and dependency injection. So if you're using an IOC container, you can do interception quite easily. And it's basically you're saying, take that pattern of do something, then run the original code, then do something else at the end of it, and you're implementing that pattern within what's called an interceptor. It's very easy to do if you already have IOC in your application. Ioweaving is completely different. So when you write your code, you then go and compile it, and it goes off, if you're doing C# to the CS.exe file, right? And that's the compiler. Well, an Ioweaver would then take the output, DLLs, EXEs, whatever they are, and say, I'm going to recompile those. So it goes into those compiled files and recompiles them and injects in the aspects at an IL level. So you get a new set of EXEs, DLLs, that look, when you decompile those, they look different than the original ones because they've got all these aspects in them. This is very non-invasive when it comes to changing your code base to implement it. All you have to do is say, add the aspects here, here, and here, and it alters the code after the fact. You don't have to go in and add any new stuff in your code at all. People think that this is by far the scariest way. How many of you feel comfortable with some other system recompiling your code right now? Yeah, not very many of you, right? It's the biggest thing that people fear. Any of the Ioweaving AOP tools out there that I've played with are really good about not screwing up your code. You know, this is their name that they have to protect. If they change the way your code functions outside of the aspects being added in, they're doing bad things for their name. So it's not as scary as people think it is, but it will be the hardest thing to get over, is that fear. So interception is IOC containers, and it follows the really strict decorator pattern. Decorator pattern says we take an existing piece of code, we add functionality around it, but we don't change the functionality that's there. So we add something before and after, we can wrap it in a try catch and do the exception handling. It's implemented using weak typing. This is a big negative in my mind for interception. When you look at the interceptors we'll have on a slide here in a second, everything being passed in, so parameters to a method call, outputs from a function, are all typed object. So if you want to work with the parameters coming in, you have to cast them. Cast to string, cast to whatever, and that takes processing power. And it's also prone to failure because you might cast it to something it's not, and you get errors then. Interception only happens at runtime. So it doesn't do anything at the compilation time of the code. When you execute your code, the interception happens then. And all it is just saying, well, instead of starting this method, I'll start this other one first and then go to that one after the fact. It's really easy to apply this en masse. So if you're familiar with IOC containers, you can register objects into them and say, register everything from this namespace. When you say that, you say, register everything from this namespace and apply this aspect to it. And you're done. All your classes in your services namespace now have logging, or they have whatever aspect you've put onto them. And it's that quick and easy. The danger there is that because they're weak typed and only getting objects out of them, that you may have some problem with unexpected types as a result of that. So if you've got IOC in your code base, really easy to implement. If you're not using IOC, you're going to have to rejig all your code to use IOC to do this type of aspect-oriented programming. So if you've got a big code base with no inversion of control container in it, I would not recommend going down this route unless you're already planning to transition IOC into your code base. So here's our decorator pattern. We got code that already exists. We can inject functionality before, functionality after, exception handling around it. Our weak typing, it's really hard to see, but over here, we're looking here, invocation. So invocation is the original call that was happening, and we're saying invocation.arguments, and it's coming back with an array of objects. So all of the parameters being passed in are just an array of object type. So if you want to do anything with them, you have to cast each one. They're supposed to come in the order that they appear in the parameter list when you define the method. I've never seen that fail, but I don't know that I trust it either. There's another array that comes off of this, I'm not sure which one it is there, that gives you the list of the parameter names. So if it's string customer name, in this array you get the value, in the other array you get the customer name is what value you find. And they actually match up. So the first index of the array is are matched together, the second are matched together, that kind of thing. Here's our example of attaching everything en masse. Our IOC container here is registering everything in this assembly that is in the same namespace as customer service. We're saying with service, so implement using the interfaces, make it transient, then configure it so that each object has my interceptor attached to it. Everything in that namespace now has my interceptor. This could be logging. This could be transaction management or something like that. Pretty simple to add it in if you have IOC. Other option that we have other than interceptors is IO weaving. And if you need to do really powerful AOP stuff, this is the way you have to go. Interception is the decorator pattern, nothing else. IO weaving lets you do all kinds of crazy shit. It's a post-compilation process, as I said before. You compile using csc.exe or vbc.exe. Then you run it through your post-compilation, your AOP framework, changes the code at an IL level, and it's really scary, but you'll be okay with it, don't worry. The thing that you can do with this is you can attach it to anything. So the decorator pattern is very much driven off of method calls. Not properties, not events, not class level, just method level stuff. You can sort of do properties, because properties in IL, or when code runs, properties look like methods to the compiler. So you attach to methods, which really are properties, but it's really ugly because you got to filter based on name if it starts with get underscore or set underscore, things like that. With IL weaving, you can attach to anything that's a construct inside of .NET at the IL level. You want to put, when you want to trigger something to happen when an event is wired up, so you do a plus equals on an event, yeah, you can do that. When it's unwired, you can do that. Do you want to add an interface to a class but not write the code for it? Have the aspect add that interface for you? Absolutely. You can implement iDisposable just by adding an aspect to your class, and it'll implement the iDisposable interface and the method for you and all that kind of stuff. So you can do really, really complicated things at an IL level with this. The thing that's really interesting with the way the process happens in post-compilation is that usually that step is actually executing the aspect code while it's doing the weaving. So you can do things like the post-compilation process will validate the aspect. Should it be on this type of class? Is it configured properly? So now at compile time, you can throw errors out and say, you know what? We don't want to have our UI layer talking directly to the data access layer. And you can have an aspect attached that will throw a compile time error saying that this is happening. So you're doing architectural validation with AOP. So this is something that's quite useful if you have a really junior team maybe, or a really big code base with this one programmer that always sneaks around and does shit the wrong way. You can trap them with this kind of thing, right? And all you're doing is trying to improve the code base in the long run. Ioweaving's really easy to add to an existing code base as well. So interceptors, we have to have IOC. If you don't have IOC in your code base, you've got to go and add IOC in and then do interceptors. With Ioweaving, you can just go into any old code base, doesn't matter how ugly it is, and just say, throw an aspect around here. So if you're working on a big legacy maintenance project and it's got really bad logging in it, all you have to do is go in and start adding logging attributes to different methods and classes, and you're getting improved logging out of it. It's that easy. So this is great for legacy code bases for that kind of thing. So the process is, you write your code, you compile your application, you get an EXE or a DLL out of it, then you get that put into this AOP post-processor. It might throw a compile time error saying Joe over there tried to do data access from the code behind in his UI stuff. Or it might just output the EXE and DLL again. It's the exact same name, the DLL. If you're doing signing of your classes, there's ways to ensure that it's still a signed class and stuff like that. And then you can go out and deploy it. So these are all the constructs that you can use Ioweaving against. You use it against methods, properties, field level variables, events, event registration. You can do interface implementations. You can add methods to classes. So you can do microcode generation with it. iNotify property change sucks to implement. You can do it with one aspect and just put an attribute on it and say, this one gets iNotify property change. And it'll add the events, it'll add all of the code to the getters and setters that are necessary and everything for you. So that's microcode generation happening with an aspect then. So the big difference between runtime and compile time is when the aspects execute. So during a runtime execution, we're going to have whatever you wrote in your aspect code. It just executes like it's part of the application. And with a good AOP tool, you can debug through your code and straight into the aspect class and then back to your code again. So the debugging story is really good with it usually. The compile time execution is when you're doing things like validation. You can fail if an aspect is attempting to be added to something it shouldn't be added to and things like that. This is the compile time's the rarer thing I see people doing. They usually have some other process or they don't care about the process. So when we've got these two different kinds of AOP, we need to look at what tools are available for them. For interception, we're tied to IOC containers. How many people here are using IOC in their code base? Fair number of you? Few of you? So if you've got IOC, you're probably using something like AutoFac or Ninject, maybe Structure Map, possibly Castle Windsor. It's a little old now, though. There's a few other ones as well. Some of the IOC containers don't support aspect-oriented programming, interceptors all that well. These four definitely do. I've used all four of them on different projects, and it works. They all work fine. With Ioweaving, your choices are much smaller. You have PostSharp and LinFoo. There's a couple other .NET frameworks you might run into out there. You could run into, I believe it's called Sheep AOP. I don't know why they named it that, but it hasn't been updated. The last time I checked, it hadn't been updated for 3 or 4 years. So I don't include it in the list because it's pretty old. LinFoo, I believe, is no longer being developed on. I think that the developer for that has just decided he's going to go off and do other things with it. It's a really robust framework, though. It doesn't need any new features, really. PostSharp is the most active of all of the IL weaving. There's a new version coming out in the next month or so here. They usually release something every 2 years, roughly, for major releases of it. And that's the one, when I talk about IL weaving, that I'm going to use for examples, is that one, because it is the most robust framework out there. Other difference here is paid versus not paid. All the IOC containers are open source, so they're essentially free. LinFoo is open source. PostSharp is a paid license tool. So that's a difference there. So if you go into your offices and say, we're going to do AOP because some dumbass from Canada told us we should, you're going to have to make some better arguments than that. First thing that people are going to say, experienced developers that have seen it before will say, is it's magic. We don't know what's happening, where it's happening, when it's happening, because it just happens. You don't see the code. It's not do logging, run whatever business logic, do logging. It's not that visible. My response to that is that's not an AOP problem. That's a tooling problem, right? The AOP tools that have been used didn't display that there was an aspect being used on that code after compile had been done or during runtime or whatever. The tools are getting better at that. So PostSharp is probably the best at it. It shows little highlighting in Visual Studio. You can hover the mouse over it. It'll tell you what aspects are attached. There's add-ons for ReSharper that help with showing the IOC container ones. But it's the biggest hurdle that I hear from senior developers. The other one is we won't be able to debug properly, and that one's just a crock. Any tool out there that's being used, you can just debug line and straight into your aspect and back out, and you'll see every step of the execution. There's no problem with debugging with any of these. Knowing when and where aspects are executed is the same problem as it's magic. People don't understand where they're being done, so they call it magic. The training point on AOP is something that people struggle with and organizations struggle with. The guys at PostSharp make the argument that you can implement AOP by only having a select few of your senior developers do the aspect generation and attachment and stuff in the code base. And it's a valid point. I'm not a big fan of that. I like everyone on the team to kind of understand what's going on, so I can go out at 2 o'clock in the afternoon and have drinks. But it is something that you can do if you need to get around this problem. And another one is this idea that these magic aspects are attached all over in the code base, and this is a form of tight coupling, and tight coupling means that it's really hard to change something without affecting something else. And there's some truth to that logic. The thing that you can do is add in, when you're using an IL weaving one, you can add in validation to ensure that changes aren't breaking changes. With something that is interception-based, you're working with weak typing now, and it's a lot harder to do stuff. You kind of got to test it at runtime. So that one, there's a failure point there that you need to worry about. We'll skip over that. I think we've talked about all this. So this is a good quote of mine that I like from I don't know where. Another thing we have to learn. If you're scared about teaching people on your team something and the fact that they're going to leave, you should be really scared about the fact you don't teach something to them and they stay, right? I'd rather teach and have good people and then have them leave and reteach and have another good person than not teach and just have some guy or girl that doesn't learn anything and does things the same way for 10 years. Okay. So we've already got this established code base, which I'm guessing almost all of you are in this scenario. It's a rare person who sits at a conference and doesn't have code to go home to, or a job to go to either. So you probably have existing code. IOC-based stuff is really hard to do with that, unless you have IOC in there. So don't think, I'm going to go do AOP, I'm going to do interception in my code base. Oh yeah, let's add IOC. Adding IOC to your code base is a massive refactoring process. You know, I've looked at code bases that are only maybe 50 to 100,000 lines of code, and we do time estimates in the months to add IOC in. You don't want to take that on just to have cleaner logging or something like that. The value return just isn't there. So if you're in that existing code base and you don't have IOC, look at Ioweaving. You don't have to spend as much money on time and people refactoring code. You don't have to accept the risk of refactoring the code, but you do have to outlay a little bit of money for a product probably. So the cost benefit is much better going with Ioweaving. If you have IOC in the code base, it's really easy, as long as what you're trying to do is a decorator pattern. So if you're trying to do something like add iNotify property change, you're not going to be able to do that with the decorator pattern. Decorator pattern won't let you add the interface. It won't let you add the method calls, the events, all those things. So it's for simpler AOP scenarios. If you've got a new project starting up, my personal preference is to go with Ioweaving. And the reason for that is because I regularly run into scenarios down the road where I want to do one of the more complicated AOP scenarios. I might start out with, yeah, we'll just use it for logging, and we'll use it for transaction management. But now all of a sudden, I want to do event aggregator registration, deregistration, and message transmitting. Well, I'm not doing that with interceptors. So I want to go in and do something that is, give myself room to grow from the start. There's nothing wrong with going the IOC route, especially if it's the first project that you're doing AOP on, and you already plan on putting IOC into the code base. Because it's really easy to pull it out. It's as easy to put it in and pull it out as taking one line of code away in some cases. So this gives you the ability to kind of test it and play with it a little bit. You put it in, yeah, it's not working quite the way we want it, you pull it out. Put it back in a few weeks later when you've thought about it some more, and then maybe pull it out after that. Ooh, last slide. So there was one other point I wanted to make that jumped in my head and just left. One of the things we didn't talk about in the arguments against AOP is people will say, when you add aspects to the code, it really, really hurts performance, right? We're running extra code. The performance is going to be awful. My first question when I have clients say that to me is, so where's your performance testing plan? Because they usually don't have one, so they don't know what the performance is to begin with. The second thing is your aspects under 90%, maybe even 99% of the scenarios, your aspects will run as fast as you write the code in them to run. You won't notice it. If you write a really crappy aspect, it's going to run slow. You put a thread sleep in it, yeah, it's going to slow down. If you put the set of nested loops in it, probably going to slow down. But I've built logging aspects that look at all the parameters coming in to a method call, loop over all of them, and if they're, look to see if they're complex objects or primitives, and if they're complex objects, look at all the properties on those, and if they're collections of objects, look at all the objects in the collections and all the properties on those, and build out the list of all the values passed in. So it's super handy if you're debugging an application to know exactly what was passed into a method and do exactly the same thing on what was returned out. And it didn't slow down the code base. That said, I just had a project I came off of where we pulled the logging aspects off the code base because they were causing a performance problem. We were parsing about 500 gigabytes of data every night through an application, and we had logging on every single method call. So you would look at a file, 500 gigabytes of data in this file, and it would look at one line, and there might be 50 data points on that line. Well, we'd loop over the fact we're going on, or log the fact we're going on the line, then log the fact we're parsing the first piece of data, the second piece of data, the third piece of data. So we're logging every single thing in there. And we were generating twice as much data in the log file as we were generating out of the process. Pulled it all off and performance went up. But we were excessively logging for something we didn't need to there. So there are scenarios where it could kill performance, but it's going to be under extreme load. It's not going to be when Joe user clicks the save button. It's going to be in something like batch processing when this happens, or big processes when this happens. So don't let people say that it's a bad performing thing until they prove, or you prove, that it poorly performs in your environment for your scenario. So that's all I got for AOP. It's very much an introduction thing. If you want to talk more about it, I'm going to hang out there somewhere. And we can talk about some of the more advanced stuff. And yeah, thanks for coming.